The universe behaves in a remarkably consistent way. Apples fall, light bends, electrons repel each other. From the dance of galaxies to the flicker of atoms, everything follows a set of rules, the laws of physics. But here's a deeper question. Where did those rules come from? Why do they exist at all? Are they eternal, like divine truths? Or are they contingent, emerging only with our universe, and possibly different elsewhere? Understanding the origin of the laws of physics is not just an abstract curiosity, it may be the key to unlocking why anything exists at all. Let's begin with what we know. The laws of physics are mathematical relationships that describe how the universe behaves. These include Newton's laws of motion, Einstein's relativity, quantum mechanics, thermodynamics, and more. They allow us to predict how systems evolve, from falling apples to merging black holes. But here's what's strange. Why are these laws so precise, so elegant, so comprehensible? Option 1. The laws are discovered. Many scientists and philosophers, from Galileo to Einstein, believed that the laws of physics are discovered, not invented. That is, they are built into the fabric of reality itself, existing independently of us. We are like archaeologists, brushing away cosmic dust to reveal deeper truths. In this view, the universe operates like a giant machine, and we're slowly deciphering its blueprint. But that raises another question. Why this machine? Why not another? Why a universe governed by mathematics, rather than chaos or randomness? Option 2. The laws are emergent. Some physicists suggest that the laws of physics may be emergent properties, not fundamental truths, but outcomes of deeper, more abstract processes. For example, thermodynamics. The laws of heat and entropy emerge from the statistical behavior of countless particles. Similarly, space and time might emerge from quantum entanglement. Could the entire set of physical laws be emergent from something even more basic? This would mean the laws we see today are not fixed, but evolved, shaped by the conditions of our universe, like physical habits that formed after the Big Bang. In this scenario, the early universe might have explored many sets of physical laws before settling into a stable configuration, a kind of cosmic natural selection. Option 3. The multiverse perspective. If the multiverse is real, with countless universes bubbling into existence, each with its own physical constants, then the laws of physics may be local, not universal. We experience this particular set of laws because we exist in a universe that permits life. In another bubble universe, the speed of light might be different, or gravity might be repulsive. Those universes might be unstable, short-lived, or completely alien. This leads to an anthropic explanation. We observe these laws because only with these laws could observers like us arise. But critics argue this shifts explanation to chance, replacing wonder with statistics. Is there no deeper reason for the laws? Option 4. The mathematical universe. Physicist Max Tegmark proposes that the universe is a mathematical structure, not just described by math, but made of math. In this radical view, every mathematically self-consistent structure exists as a universe. We happen to inhabit one that supports complexity and consciousness. The laws of physics are not imposed. They are the necessary truths of the mathematical structure we call home. This theory blurs the line between physics and pure math. But it raises another question. Why math? Why does abstract logic give rise to concrete reality? Option 5. The simulation hypothesis. Again, if our universe is a simulation, then the laws of physics might simply be all code. Programmed rules written by a higher intelligence. Like the laws in a video game, they may be arbitrary, tweakable, and even patchable. This brings us back to design, but not necessarily divine. In this view, the laws of physics are chosen parameters within a grand simulation engine. If we're in version 3.0 of the cosmos, who chose the constants? And could they be changed? Are laws really constant? Recent research suggests that some constants, like the fine structure constant, may vary slightly over cosmic time or across space. If confirmed, this would shatter the idea that the laws are immutable. It might also mean that we're catching the laws in the act of how evolving, like watching the rules of chess change mid-game. So maybe the laws are not fixed after all. Maybe they're fluid, responsive, or even creative in nature. Deeper still, are laws a human construct? Some philosophers argue that the laws of physics can't exist independently, that they are just our models to describe patterns we observe. The universe doesn't follow laws. It just is. We impose structure onto chaos to make sense of it. But if so, then how do our mathematical models work so well? As physicist Eugene Wigner asked, why is mathematics so unreasonably effective in the natural sciences? It's a question with no easy answer. At Infinity Beyond, we don't claim to know who or what wrote the laws of physics, but we believe the question is worth asking, not just to understand the cosmos, but to understand our place in it. Whether these laws were discovered, evolved, chosen, or created, they are what make the universe comprehensible. They allow us to build rockets, split atoms, measure black holes, and record thoughts like this one. And perhaps, in asking why the laws exist, we are glimpsing a level of reality even deeper than science has reached. In our next episode, we'll explore the strangest law of them all, entropy, and ask, why does everything tend toward disorder? And could entropy hold the key to time, consciousness, and the arrow of existence? Subscribe now to Infinity Beyond, and keep following the cosmic code wherever it leads.